This presentation will demonstrate how to configure IPv6 EIGRP, as well as to demonstrate the differences between real equipment and packet tracer. This is the topology we're going to use to demonstrate how to configure IPv6 EIGRP. Branch 2 and Branch 3 were pre-configured with EIGRP. We're going to demonstrate using Branch 1. When enabling IPv6 EIGRP on a router, you must first make sure IPv6 unicast routing is enabled, or you will receive an error message. Once that is configured, we can go ahead and enable EIGRP on the router along with the router ID. The EIGRP router ID is normally selected in the same manner as OSPF. The highest IP address assigned to a loopback interface is selected as the router ID. If there are not any loopback addresses configured, the highest IP address assigned to any other interface is chosen as the router ID. Or we can simply hard code the router ID using the EIGRP router ID command. The purpose of the EIGRP router ID is used as a loop prevention mechanism for external routes. Notice how there are two different command sets for real equipment and in packet tracer. In order to enable IPv6 EIGRP in packet tracer, you enter the IPv6 EIGRP process ID, then configure a router ID followed by the no shutdown command. The no shutdown command enables the IPv6 EIGRP process in packet tracer, but not necessary on real equipment. Notice the difference in commands when using real equipment. You enter the IPv6 router process ID number, followed by the router ID command. When using real equipment, you can use either the EIGRP router ID command or just router ID with the address. When you issue the show run command, it will display the router ID with EIGRP before it. Let's go ahead and configure Branch 1 in packet tracer with IPv6 EIGRP. As you can see, the error message appeared when IPv6 unicast routing wasn't enabled. If we fail to enter the no shutdown command, the IPv6 EIGRP routing process will not be enabled. As you notice in the running configuration, it says shutdown. Now let's go to PuTTY and enter the commands on real equipment. Again, the error message appeared because IPv6 unicast routing wasn't enabled. Now if I go into the running configuration, you'll notice that it doesn't say shutdown where EIGRP is. And if you also notice, it says EIGRP router ID, even though all we entered was the router ID command. Unlike IPv4 EIGRP, IPv6 EIGRP does not require the use of the network command to advertise its networks. Instead, IPv6 EIGRP must be enabled on all of the router's interfaces. This command must be configured on all of the router's interfaces that are participating in EIGRP. If we fail to configure this command on an interface, that network will not be advertised. Therefore, it will not be learned by its neighbors. When IPv6 EIGRP is configured on all interfaces, a log message will inform you that an adjacency has been formed. Now let's go to Packet Tracer and configure the interfaces to participate in EIGRP. Notice how no adjacencies are formed. This is because we didn't enable the IPv6 EIGRP routing process using the no shutdown command. Once the command is entered, an adjacency is formed. Now let's go to Branch 1 in real equipment and compare the difference. Notice how an adjacency forms once I enable EIGRP on the serial interface. Let's issue the show IP route command and notice how nothing is being displayed. This is because the table is for all IPv4 networks, but since we are using IPv6, we have to issue the show IPv6 route command. Notice how branch 1 has learned networks from the other routers as evidenced by the D in the IPv6 routing table. The L in the routing table is a new identifier which indicates a specific address assigned to an interface, as opposed to the C, which only displays the subnet. You also notice that the L displays a 128-bit prefix, where the C displays the actual prefix configured on the interface. This is the show IPv6 EIGRP neighbor command. As you notice, the link local address is used to identify neighboring IPv6 EIGRP routers. The show IPv6 protocols command first displays that its routing protocol being used is EIGRP 100. Then it displays the K metrics. And then if you notice below that, it says interfaces, serial 0/0/0 and serial 0/0/1. These are the interfaces that are participating or enabled for the EIGRP IPv6. And on the bottom you see it says distance, internal 90, external 170. This is the administrative distances for EIGRP. The show IPv6 route command displays more learned routes, as well as the C's, which are directly connected, and the L's, which are the interface addresses. The passive interface command is not currently supported by the current version of Packet Tracer for IPv6 EIGRP, but hopefully it will be added to a future version. You can use the passive interface command to control the advertisement of routing information. The command enables the suppression of routing updates over some interfaces, while allows updates to be exchanged normally over other interfaces. When used with EIGRP, it suppresses the exchange of hello packets between routers, which will result in the loss of a neighbor relationship. Therefore, it is only used on interfaces where no routers are connected. This stops not only routing updates from being advertised, but it also suppresses incoming routing updates. The configuration is the same as with IPv4 EIGRP. Now let's go to PuTTY and configure the show IPv6 protocol command and discuss how it shows the gigabit interfaces are participating in EIGRP. You notice that it shows not only gigabit interfaces, but the serial interface as well. Now we're going to enter the passive interface command and suppress routing updates from being sent across the gigabit interfaces. Now let's go back to the show IPv6 protocol command and notice how it displays passive next to the gigabit interfaces. This tells you that the passive interface command was enabled. Now we're going to summarize branch 3's LANs into one summary address and then advertise it to branch 2. Summarized addresses are based on common bits in the network portion of the address. These two networks have 63 bits in common. As you can see, they have 16 bits in common in the first 3 hextets and 15 bits in the 4th hextet, giving you 63 bits in total. Therefore, the summary address would be 2001:db8:acad:/63. To advertise the summary address, issue the IPv6 summary address EIGRP AS address command and apply it to an interface where you would like the address to be advertised. This is applied to the serial interface that's connected to branch 2. This command is only entered on interfaces that connect to other routers. Before we configure the summary route on branch 3, let's go into branch 2 and issue the show IPv6 route command. Here you'll notice how both routes are visible in the routing table. Now let's go ahead and configure the summary route on branch 3's serial 0/0/1 interface. This is the interface that connects to branch 2. Now, if branch 3 were connected to another router, say branch 4 on its 00/0 interface, we would configure the same command on that interface as well. Now let's go back to branch 2 and issue the show IPv6 route command. But first, did you notice how it changed the neighbor adjacency? A log message appeared displaying this. In branch 2, notice how it replaced the two routes with one summary route with a prefix of 63. Normally, if a specific route to a particular network does not exist, a router will drop all traffic destined to that network. A default route, or gateway of last resort, allows traffic to be forwarded even without a specific route to a particular network listed in the routing table. With IPv6, a default route is identified using the IPv6 route : /0, the exit interface, the next hop router, or a fully specified route which uses both the exit interface and the address of the next hop router. We are going to configure a default route on branch 2 pointing to its loopback interface. This will be used to simulate the internet. In order to propagate the default route, we enter the redistribute static command in IPv6 router mode. This slide shows the difference between the router that configured the default route, in this case branch 2, and the output of the router that learned the default route, branch 1. The default route configured on branch 2 is displayed as a static route via the loopback interface. Branch 1 displays the default route in its routing table as an external route. The only differences between IPv4 EIGRP and IPv6 EIGRP is 1, there is no asterisk shown on the device that creates the default route, and 2, it doesn't display the gateway of last resort. This completes my presentation on IPv6 EIGRP. I hope this was a helpful demonstration, and may your networks continue to converge.